G'day guys, Andrew Dwight here. Hey, today we're going to talk about structure, and probably a lot of builders and frame and truss manufacturers really only care about the structure. They don't care about the aesthetics other than getting the job done so that they can deliver a product to site. And I've had a fair few questions that I thought I'd just go through today, and the first one is walls. How do I get a taker from walls? And I think there's plenty of videos on it, guys. I might briefly touch on it later. Beams and headers. How do we size them, calculate them, take them off? Extra structural material for point loads, which we'll go through, which is essentially Plusspec by default is drawing a wall, and as you'll just see by this wall here, it's pretty long, and we know that we don't buy lumber this long, and there's ways that we would divide it up, and there's some workflow methodology that we use to make sure that we get the most out of our production and also out of the lumber that we can purchase off the shelf. We have strong backs. How do we deal with that? Plumb and align material. I'm not sure what that actually means. I've just copied and pasted this in here. Floor framing materials, joists. That's all in there already, guys. There's plenty of videos on how to change floor. We'll just touch on it briefly. Sheathing on the outside, shear walls, and how do we associate them with the model. And that's probably the main thing we'll go through today, is how do we associate things with walls so it's all taken off correctly. OSB around windows and doors, that's another thing. There's videos on it at the moment. However, inside of the wall tool, you would select OSB in your framing mode, and it will also show. And when we click on this tab up here, it would show it as well. I'm not sure if I have it. I actually do have it. This one's ply lined, and it's you can see that the sheets are horizontal. Roof framing not included in the truss pack. That's pretty simple to do. We'll have a look at that as well. Roof sheathing, that's a very similar thing to the OSB. That can already be done. A starter board, I'm not sure what the terminology is. This is an American question, so I'd have to find out a little bit more about that, and please, by all means, add some notes and starter board there to help me out. Fascia, how do we deal with that? Hardware, hangers, straps, strong walls. Okay. So we're going to go through this briefly. It's not really a tutorial, it's just showing you how I would go about doing it. And so first things first, I have a model here. I'm going to select my wall. I'm going to, and just do a takeoff on one wall. It's going to be brief. Actually, I'll do 3 walls, and then there might be a couple of different ways to show it. So essentially, I've got my wall height. Obviously, it's 8 feet or imperial metric, doesn't matter. Your header height, which is the top of your windows and doors. Is it a structural wall? In this case, external walls here would be, and this is the first floor, so internals probably wouldn't be. So internal walls, I would turn that off. Timber or lumber that we're using to do it, and the stud spacings, I'm working in metric, so 600 millimeters is usually a standard spacing in Australia. However, 16 on center in America, you just type in 16 inches or 14 or whatever it is. And how many top plates, bottom plates, your headers, whether you want your headers to line up with the inside or the outside or both. Nogging and blocking. In Australia we call it nogging, called blocking in the States, and essentially we put that in for either to fix your OSB sheathing to, or to, in Australia we use it basically to space the studs. We don't have as many restrictions on seismic and bracing. Okay, and you can also put in your blocking spacing here. We get straight into it, and you can change these as you go. You might want to say this is, different stud size or whatever. I'm just going to quickly draw 3 walls, as I mentioned before. Let's start over here. You know what? We're not getting too caught up here. I've got 2 options. Is I can click here and double click, and I can put 1 wall in there. And if we want to look at the structure here, probably should keep it in the structure mode. You can just see that we've got 1 wall there. And what I might do is, just to make this a little bit easier, I'm going to go over to my layers over here, and essentially what I'm going to do is I'm going to send this out, and just so we can have a look at what's going on here, I'm going to find my layers, and I actually want to work in my structure view here, but I want to see the plan underneath, so I'm just going to quickly go down and find my imported plans, which is a PDF which you can import straight in, or you can import a DWG. Imported floor plan, and now I have that. I'm just going to create another scene at the top here, right click, add, so that way every time I want to look at this particular view I can. Right, and now I need to get back into my wall, And I've just done this wall with a square end on it, okay, because that would be how we'd probably build it in a factory. However, a lot of factories are now starting to miter their corners, and there are advantages to it. I know a lot of people sort of go, no, why would you do that? However, now we're using, you know, better quality, better technology saws. We would potentially miter these because it just makes it easier to know the left and right of the wall when you're standing them up. However, whichever way you do it is up to you. Okay, so now I've drawn those walls there. If I did a bill of quantities here, for a second. If I did a bill of quantities here, essentially you'll see here's all the lumber, here's my 41 blocks that are in between the studs. If I turn them off, obviously not going to come out. My studs and the length of the cut length of these studs, which is really important, especially if you're using an automated saw. Let's go back to that model. Okay, and I'm going to put some windows in, and you can see here that we have 2 windows here. I don't need to get caught up in heights and sizes because it's just a tutorial, but I'm just going to add a window. And inside of my window, it will automatically place a header according to what was chosen in the last dialog, but I can also change it here. So lumber, I don't really recommend at this stage to go through and size because you don't know where a point load is above it, and we're going to get into that a little bit further. I'm just going to put in 2 windows here, see what size I've got. I'm going to make them a little bit taller. Actually, let's make them say 1500, which is 5 feet. Window here. You know, and the next one might only be 3 feet. You can just basically, you can see what happened there. I'll show you in a bit more detail. Next window here, and you can choose standard size windows, whatever it is. So essentially, it put in my my studs, and it also highlighted these red because it's more than likely going to be a point load. Plusspec isn't an engineering piece of software. However, if you combine it with an engineer or you combine it with an engineering piece of software, you can size all of these as it would be built. Okay, and the reason I didn't worry too much about my header size is because I don't know what's above this. There could be a girder truss or something above that, and you would usually go ahead and do that. Now, if I just wanted to do a takeoff on one wall here, if I select everything, which is Control A, and I just highlighted the ones that I don't want to do and went hide, right? I actually should have gone the other way. Control Z that. Oh, I actually want to hide this one, this one, this one, and this one, and go hide. It will just do a takeoff of this wall. So when I do a takeoff, now I only have the studs that are associated with this wall, the bottom plates, and the headers, right? So it's very easy to get a cut list and associate it with a wall. Inside of Plusspec, every wall has a name. So in this particular one here, this is wall 3, and if I actually Control Z and unhid those, unhid those walls, Control Z, right, all walls have a name. So you might just want to do a takeoff on wall 3 or on wall 4, right, however you want to do it. If you actually label the timber, it'll tell you the name of the piece of lumber. In that case, it was a stud. So if I want to do a takeoff on wall 3, I can go Control A, select this one, and then hide. So right click, hide, and now I'll just do a takeoff on that one. I'm going to Control Z it and bring it back. So I hope that helps clarify how we would go about doing a takeoff. Now, before I mentioned as well that we drew this wall long and we can't buy lumber in this size. There's a couple of ways, and guys, we do deliver specific tutorials or one-on-one training according to the user and what they want to do, because there's a lot to Plusspec. However, it's easy to use if you just break it down into your sector of the industry. And breaking walls down into sizes and associating blocking for walls or junctions and other framing items is what I'm going to get into next. Okay, so in many cases, beams and headers, I think I covered that. However, we might get into it in a bit more detail later on and how to go about sizing them. But essentially, inside of the wall tool, you can change the size of these headers according to the weight that's going to be put on them, and it's usually an engineer's job, or you might use a particular piece of software. I use one called Design It. There's one called Smart Frame. There's several different frames, and also just a span table could probably also do the same thing. We have the capacity to add it in here, guys. No one's really requesting it, so we don't. However, we are getting into sizing of joists and everything according to manufacturer sizes, and we can also get into other things there, but at the moment we're just trying to cover these questions. Extra structural material for point loads. So I guess a good example of that may be if you had a girder truss going over top of a window, or a girder truss sitting in a wall in between a stud spacing, say for instance here. So we might have a point load right here, okay, and this might have a heap of weight on it. Now, or it could also have a beam that was going to come out. So here's a new functionality that a lot of people don't know is there. Okay, what we have is an option to add object to wall, and there's several reasons you might do it. It might be hold downs, it might be bracing, it might be, in this case, a load bearing item. Now, it could be a steel stud, it could be a lumber stud, LVL, it could be anything, and you can choose a size in there according to what it might need to be done, or you can create your own size. You might have your own way of doing things, and essentially I could just go from here and I could basically put in a piece of timber, and it could go several different ways, and if you use your down arrow key, it will also change the location of the draw. I might put it here. Okay. Now, the problem is that when I go and move a wall or split a wall, this has no association. You can notice when I hit the wall, it's blue. However, this isn't associated with two separate items. Now, here's the best way to do this. If you push, select the wall like I've done there, and select the object, it could be anything, and go right click, walls, you'll notice in here, add object to wall. Okay, and now I have that piece of lumber associated with that wall. If I went and put a window in here, it's going to stay there because we've sort of done this, and the architect might come back and say, hey, we want to put a window in here. Well, it's a good idea to actually have this functionality, because if we wanted to add a window after it had been structurally detailed, the load bearing stud's still going to stay there, which is a good thing. You can delete it. However, now I know, oh wow, we either need to upgrade our size of our head and then take this out of the wall, so I can go walls, delete object from wall, right? And now I've actually deleted that object from the wall, and now I could upgrade the size of my header, and that's probably, you know, a really important piece of thing. I'm going to just Control Z it and put it back in there. And I'll probably Control Z. Control Z is basically undo, guys, if you're not aware of. Also, I mentioned that you may want to add things like bolts. I'm going to use a shortcut that I set up called Control Hide, or Hide Rest of Model, right? And essentially, you can see that I have a bolt there, and it could be a hold down bolt that you're going to go into concrete with, and so on. And you can see that that's been associated with the wall as well. I can associate this bolt with anything. And all I did to create this bolt was I actually just went out here and drew a really low poly bolt, because all I needed to do was whatever. So you just, obviously this is huge, but you get what I'm talking about. And what I could do is I could pull the top of the bolt up, and I could and call it a bolt. And the BIM tool is really important for that. So if I selected that 3 times, I can either go to my BIM tool, or I can right click and I can make BIM object. And you can associate a brand, a URL, or anything with this bolt. And it's probably good that it's so big, so it'll stand out. And you can call it whatever you want it to be, an item code. You can put on a layer, so it'll always estimate the right spot. I might say in this case engineering. And it's a big bolt. Big bolt. Typing's terrible, apologies. Brand, URL, and everything, and maybe even location you want to associate it with it there, and even price. So especially if you're a frame and truss manufacturer, you're going to want to install, because it's such a big bolt, I'm going to make it $1,500. That's the install price. That's what you'd charge to install that bolt, because it's such a big bolt. And the purchase price might be $500, and you might even want to write who you're going to buy it from. So you might say Simpson. Strong die. Okay, and a URL. Let's quickly grab a URL. Let's just go say Plusspec. Oops. And this website is basically where you will get a lot more information on this type of functionality. I'm just going to take this URL, Control C, and I'm going to go back to here, and I'm going to put my URL inside of my component. Oops, hide it there, Control V, and go submit. Right, so I have this big bolt here. Right, if I did a takeoff under engineering, because it's the layer I put it on, you'll notice that I have one big bolt, spelt very poorly, $5,000 to buy it, and $1,500 to install it. Right, so it's $6,500 for that bolt. Obviously, if I go and put in several bolts, or associate them with a frame, I'll grab this big bolt and I'll associate it. I'm going to move it over to say here, and we want to put 5 of these big bolts in the frame, right? So I'm going to move it. I'm going to say, well, 1 there, times it by 4. Right. If I associate these 5 bolts with that frame, I can select it. I can select this frame here. Right click, walls, add objects to wall. Now when I move it, put doors in it or whatever, they'll always stay in that location. And if I do a takeoff, again, you'll notice that I'll have more big bolts. Here. Okay, so I have 5 big bolts. And shear walls was the next question. I've actually put one in there already, so I'll see if I can go through that with you. Alright, so just the same as we associated the bolts, we have shear wall. Now, in our Plusspec components, we have a few, let's just say a very minuscule amount. However, we have products in here, so there might be hangers, boots, and so on. We've just put a few in there. We know there's a lot more to go in there, and we are looking for requests on the particular types of products you want in here, because we will do it, and it's basically saves you the time of going and drawing big bolts, basically. Anyway, so I can grab this, I can submit it, and I can say, okay, I want another shear wall to be here, and probably this is more likely to be a place where a shear wall would go, because in a seismic area you have very little bracing capacity, right? I can associate this shear wall with that just the same as I have, and I'm not going to go over and over things. It's just, you know, I think you'll get it from here. If not, give us a call, book in some training, we'll show you how to do that. Okay, so let's have a look at what else we have here. OSB, essentially when you're drawing your wall, you can associate OSB with the total coverage of wall. However, you might just want to do, for some reason you're in an area that only requires a small amount of bracing, you can do the same thing. I can just use a rectangle tool and say, okay, I need to brace from here to here with a particular type of bracing. Same thing, triple click it, right click, make BIM component, and you can save these to your library if you want to. You'll probably do this over and over, and it's something we can teach on a one-on-one training. Associate it with a layer, call it what you want it to call it, bracing. You might even want to write in a size. You can do whatever you want to do, and a location, ground floor, notes about it, special bracing, whatever. And you can associate cost, more importantly, and you can associate it with a wall. I'm just going to go here, and I can then associate that with a wall as well. Right click, add components to walls. So I think that kind of helps you out with that. Let's have a look at what else we've got. Fascia, hardware, hangers, straps. I think I briefly touched on that. There is a lot in there. However, you can create your own libraries. And if you look in some of the other videos or get some training from us, we'll show you how to create your own libraries that are specific to your business. Okay, I've actually just traced these frames over a plan which was imported via here. File, import, PDF, and you can have whatever resolution you want to. This particular home is a new home. It has been built. It cost them a lot of money. They said, well, we should have done it this way to start. It would have saved them a heap of money in the prototyping of this house. However, it didn't. I'm going to undo all those big bolts and everything else that I put in there. So Control Z. I'm going to group this here. And I'm going to group my frame. Right click, make group, and what I'm going to do is I'm going to overlay it, because I just drew straight over top of the plan and I can see whether it lined up. You would hope that the designer or the architect on this particular project got it right. You'll also notice that I put in some guidelines, so when I drew the ground floor I could check before I started to go and do a whole heap of work and realizing there's a mistake in the plan. Mistakes in the plan are common, as we'd probably all be aware. They're kind of frustrating, and this is a good way to find them. Sending things out to site and costing the builder more money because there's a design error can be frustrating for the builder. It can also be frustrating for the people that are manufacturing. You might be under workload and you need to just get things out. Now, there's a real advantage of actually overlaying a frame, is now I can start to see where my point loads are transferring, and I'm going to need joists in here as well. First things first is I'm actually going to just highlight my void. There's a big stair void here. I'm going to break inside of my group, and this will all come with training. I'm going to go rectangle. I'm going to start my void from here. Excuse me. And I'm going to go over to here. Now I have my void. Oops. Right. I don't want any joists there. Right. And I'm going to go here. I'm going to right click walls. I'm going to select all of my connector walls. Oops. Select connector walls. I'm going to right click. I'm going to create a face from the walls at the base of the walls. Okay, in this particular instance, they're not actually joined. I can join the selector walls, and then I can create my walls from that. Walls, generate, face at base of walls. And now what you can see there, it's got a dotted hatch on it. Essentially, if I hide this plan, hide, you'll notice that I now have my face for there and my face around there. So, okay, and you'll also notice that I don't actually have my bottom walls turned on, because when I actually broke inside of my component, I have a thing called hide, rest, and model, and we can train you on that as we go. And I can turn it off. So Control Hide is my shortcut for it, and now I can see that my top walls are overlapping my bottom walls. In this particular instance here, the ground floor walls and the first floor walls don't actually line up, and that's just the design of this particular project. So there's going to be beams in here which I would add to wall. There's going to be a heap of things, but I'm actually going to leave that, and I'm just going to go in and say, okay, well, I want to actually see where my walls are underneath, and I can see that from here. So I might start to go through and I can either turn my first floor frames off, or I can hide them. So select them. Probably should have broken inside the component and hide them. It's actually a group, guys. Hide. And now I've got a better understanding of which way my joist may run. Right, so here I would assume my joist should run this way. Here we're going to need some type of steel, and I would assume we're going to need a piece of steel from here to here. Therefore, we're going to need to transfer load through, and we would add that of steel to the walls as well. So what I normally do first is I go and put my beams in. In this case, I'm going to go in here to my beam tool. I'm going to select a size, and I might use my engineering software to do this. I'm just going to make it 375. I'm not engineering, guys. I'm just showing you how to do it. And I'm going to go from here, and I basically put it in an LVL there, and I push my down arrow to space it. Well, that's not so good. It doesn't line up. That's cool. What I'll do is I'll move it over. Right. Oops. Push escape there. Don't push escape. Right. I probably should have actually gone from where I know is my shortest point, which is here. Change my size again. I don't know where it's going to be. 240 by 70. It could be whatever size your software, your engineering software is telling you. Right, there to there. I can move it over. I can add my structural beams to my walls. Right, and now I would assume my joists are going to make this distance from here to here, so I can take a measurement. What's the measurement from here to here? And you'll notice in the VCB down the bottom, which is here, the measurement, you can see I didn't even get that beam straight. Just kind of rushing a little bit. Right, 8 meters, which is, I don't know, 20 odd foot. It's not going to happen, so it's going to need 2 beams. I can start to figure out how this is going to work. Or I could just do this. The maximum span of my joist may be, in Australia, 300mm floor joist could span 6 meters. 6 meters. You see I type that in the bottom there and go enter. So now I can see, well, if I don't have a beam here, it's not going to happen. So I would divide my frames, and I have a void here. This is my void, so I'm going to delete that. And I can say, right, well, my joists, I'm going to go from here to here. Right, and I'm going to put my joists in here. Now we've got some really, really powerful tools in this particular area that we're working on now, which is going to help a lot. And I might say, well, what type of joist do I want to put in there? It could be a truss joist, so a web joist, so a floor truss. I can put my spacings in. I can, floor truss. I can go through, add my spacings, the size of my floor truss. I can create my own floor trusses if I want to, and say, okay, these floor trusses are going to go this way. Right, and now you can see that I have floor trusses in there, and I can also figure out where my penetrations may go through, or my piping, or HVAC, or whatever it is. And here I know that here's my maximum span of this particular type of joist. I can put another beam in, so I might go to my beam tool, add a beam and another beam, then distribute that load through the frame. It could be steel as well. Right. Choose UV. Obviously, if you're synced with the US catalog, it's going to give you imperial beam sizes. Right. And so on. Now I can basically do a bill of quantities from this. If I went hide rest of model, I can just take these joists off one by one, and I can continue going through and doing joists as I see fit, and then I can trace my load path as I go down. So I put this above the face because it needed to be there. I'm not going to get caught in doing all of them. I'm going to edit, unhide, last. Here's my frames. You can see that my frames need to go up on top of my joists, and obviously there's flooring there as well. They would go up on top of the flooring as well. And I can start to trace load path. So looking at this here, here's where I added this poster wall. You can see here that I would need to add another beam in here, or whatever you wanted to do, distribute the load between joists. But it's a good way to actually detail a job, and detail the job correctly. And the best thing is you can actually save these models, and you can send them to a mobile phone, and the contractors can look at them on site. And we can do some training on that as well if you need some training on how to do that. Contractor no longer has to pay for that app. So basically, if your contractors aren't speaking English or having troubles understanding plans, it's very easy to communicate from inside of your office how you expect this to be done on site. So as a builder, I know that some of the biggest problems I come across was point loads, being in between joists, and then buckling the bottom plate and so on. I can't see any reason for it to happen anymore. I believe that this is the best way to virtually design and build a project, and to iron out the bumps before you start, and it doesn't take long. So at the moment we're in 28 minutes of this video. However, it only took me 20 minutes to draw these frames. It's just that I'm explaining as I go. Adding objects to walls saves money, it saves time, and it enables communication. One other thing, guys, is that putting a little bolt inside of the wall over here, you can see it's kind of hard to find. Only reason why I know it's there is because I put it in there myself. However, you don't need to do that. You might say, well, you know what, I want to make it really, really clear to the contractor that I'm going to have something in here. So I might say, well, I'm going to make something really big, and I can make it colorful and easy to find. And I can make this into a component. I can call that a fixing or a tie down or whatever it is. Once you create a library, and we show you how to create a library specific to your business, you can communicate very, very easily. Let's see if there's anything else here that I've got in here. My understanding of strongbacks is that, and I could be wrong, so correct me if I am wrong, that would be a perimeter board that goes around the outside, and that's another functionality. You'll see it in your joist tool. I can select these joists over here, right click, floor joists, edit joists, and I can add a perimeter beam, which is what I would call it in Australia. However, I assume that's what a strongback is. Include perimeter beams. submit, and I might even change the joist direction, whatever it might be. And now I have blocking or a strong back, one full board going around the outside of those joists. Hope that clarifies that one for you. Plumb and aligned material. I'm not sure what that actually is referring to. I'm potentially bracing, and the same thing would be with bracing. I think I mentioned it before. Drawing what you want, associate it as a BIM component, associate it to a wall, and away you go. The main thing that you'll get out of this video is that learning to associate items with walls is very, very powerful. In this case here, you can see that there's some piers out the back here, and you would assume that from those piers would be a beam. If I go into my beam tool, I can now go and draw in my beam, and it doesn't matter. Sometimes it's easy just to draw it on the ground here and then move it up. So I've got a beam from here to here, and I might have a beam from here to here, and it could be LVL, it could be anything. Use your down arrow to justify where you want it to go. Right, it was easy for me to draw it on the floor plan. However, I actually want it to be at the right height that it's going to be. I'm just going to associate it with the wall. You can also associate a roof with a wall. You can associate anything to a wall, right? And then I go, I've got those two selected. I'm going to select this wall here, right click, walls, add object to walls. It's now part of that wall. If I move the wall, put a window in the wall, it'll outline where you have any issues. Okay, the next question was, how do we do special things with framing? Now, Plusspec has a pretty robust truss tool inside of it, and essentially here, and you can do hip trusses, Dutch gables, skew-in, so on. Look, it doesn't get into the nitty-gritty of internal load-bearing walls and so on. However, you can still do it. It's just a matter of associating items with trusses or labeling trusses or using components to do it. I'm just going to quickly put some hip trusses in here, guys. There's plenty of videos and a really good video on how to do this in more detail on the YouTube channel. Okay, and this is the pitch of our roof, the overhangs, upstand. Probably the most important thing for a frame and truss manufacturer is the setback of the first truncated truss. I'm just going to go and put these in as straight out of the box. And essentially, depending on the speed of your computer, will be how quickly they'll do it. You'll notice here that I actually had valley trusses, so if this was going to blend into another roof, if I didn't want it to do that, I'd just select it like this and then go back and change it so I don't have my valley trusses there. And you can change it to a Dutch gable or whatever you want to do. More importantly, when our first setback truncated girder truss is showing me where the point load is, you can see that this here probably should have been here to hold that up, and then we can figure out how that weight or load is going to transfer through. This one here is not too bad. It could work quite easily. As I said before, if I want to get rid of this valley truss here, I'm away. And I can just go and redraw my trusses wherever I want to go. I think you get the idea there. All right, let's have a look at what else we've got. Roof sheathing. When you go and put your roof in, let's quickly just draw a roof over here. And you can do very complex roofs. It doesn't matter whether they're different heights and so on. And just check out some of our other videos. I'm going to do something simple. Maybe just add an arc, because this would be one of the questions that's going to come from that. From my arc, I might have, say, 6 sides. Enter. And go from here to here. Oops. So to do this, I'm going to use arc, which is here, or A is a shortcut. And down the bottom here, this is the number of sides in an arc, so I'm going to say 6 and push enter. And now I'm going to go to here, and I go arc from here to here. All right, I now have 6-sided arc. If I'm going to put a roof in there, erase, you can see where I'd have trouble putting trusses in there. Okay. I'm going to create my roof, and you'll have fascia there, because there's another question in here. You can associate the overhang, the pitch or the ratio, the fascia type if it's plumb, if it's angled to be adjacent to the rafter, Soffit, what type of soffit you're going to have. There's a lot in here, guys, and this video is not about using all of this. Include capping, whatever it may be, the type of roof that you're going to use. Okay, go submit. It's a reasonably easy one to truss, except for when we get to here, and we would utilize what was I going to say? Let's go all. You would utilize a mistake there. You would utilize whatever it is. It's probably outlining a problem in that particular project. Sorry, I lost my train of thought there. Down to here, say raise. That's where my problem was. When I drew it, I should have deleted the lines properly. Roof. And the next tool that we've got coming out in regard to this particular project is to do with quantifying fascia, the lengths, the amount of men on site to put it together. It's super powerful, and it's really right up what a manufacturer needs to do. So there could be multiple different roof types, and I'll show you how to associate rafters with particular roof types. Okay, so as you can see over here, it's very easy to put these trusses in. Start with your longest truss first. Yet over here, we'll probably use stick timber to do some of this here. So what I'm going to do is I'm just going to take the face that I created this roof from, and I'm going to move it over here so we can just see what's going on. This is our pitching point, guys. I could have done it on top of a frame, and I'm going to have to do my trusses first. Roof trusses. These are hip roofs, so I'm just going to quickly go in here. I'm going to put end truss to start, and look, guys, this is in another video, so I might just quickly blast through it, just so we can see what's going on here. End truss off here. Shift. I'm not going to get too caught up in it. I need a valley truss up here. Valley truss here. From here to here. That'll create my saddle trusses. There. Now here, I'm actually going to make this into a gable because I'm going to need a girder truss. However, I could also use a beam and just pitch it. Just going to go here and go just common truss. I do want my valley trusses on, and I'm just going to go from here to here. I'm just smashing this out, guys. I haven't done the math. Right, I probably didn't want that to be a gable truss. I shouldn't have selected gable up here, just 0 gable here. So if I selected this here, right click trusses, edit truss. I don't want that to be a gable truss. Where am I here? Include gable truss, no. Submit. It's going to ask me to draw it in again. Okay, right. And then I need my roof over here, so essentially I'm going to utilize this geometry here to actually create my rafters. I'm going to go hide rested model so we can just see here. You can see that I'm going to need rafters here, here, and here. And I'm probably going to need rafters according to the distance that my setback is. I can actually go and use these faces here for rafters. And I might say, well, the distance that my gable truss is back here. So I might say from here to here, say. I actually only want to create my rafters from here to here. And look, there's a heap of ways to do this, guys. I'm just showing you one. Inside of my roof tool, I have the capacity just to add rafters, and it will automatically create rafters according to the size that you choose. Here. I'm going to go submit. You'll notice that happened underneath here is if I looked at my structure, you'll notice that it created rafters and so on. Look, there is another way to do it, is be to just utilize one of the tools inside of here, which will allow you to underpillage rafters, a whole heap of stuff. So if I went back inside of my rafter tool here, I can go and put in rafters from point to point, and that would be right down the bottom down here in alternatives. And I might want to use underpurlins, rafters from point, so I might want to draw a rafter from here to say here to, oops, probably not in the right location. Where am I? Underpurlins, rafters, draw, and I'm going to draw a rafter from some strange location from here to here, say. Right, it'll add in extra rafters. So look, there's a whole heap of way to add stick timber to rafters without any dramas. You can obviously move it to where you want it to be. It's grouped. Move it to where it was going to be here, just say roughly like that. Bang, I now have a roof. I can create a layout from here. So I might say, well, I want this to be top down and I want to label it. I can go to here and I can start to go parallel projection, camera, parallel projection. And look, we set up templates for companies to do this. And now I can go through and start to use it as a drawing that we can send out to site. However, the advantages of sending a 3D model to site, especially now that the add-on software is free, is second to none. I think it really is a huge improvement to being able to communicate with people on site. The old days of paper drawings and getting wet and on site is just ridiculous. So yeah, if I want to send this to my phone, I can send it to my phone, I can label it up, I can call the Truss's numbers, and we can have the contractors who may not be able to read English learning how to use their 3D model that you've created in your factory for an estimate. Guys, I hope it helps out. There is a lot involved in what we're doing, so by all means, any questions, ask. Cheers.